Good evening again. I'm Keith Miller, and this is the Climate Change Applied Science Workshop. And I'd like to start out giving a little background on myself and how I also got into this practice. I am a chemical engineer by degree, and I've worked most of my life, 40 years, in the environmental area. I've been an environmental engineer, also involved in environmental management. In the last 13 years of my career, was involved in sustainability, and that time included getting involved in the climate change issue. I worked for 3M for 37 of those 40 years, so most of my career. And in 1991, I was very involved in, back then, the Clean Air Act of 1990. And I was also starting to read Thich Nhat Hanh, and I had been practicing in the Soto Zen tradition up until that time for about the previous 15 years. And I went to a retreat in Malibu, California, because it drew me, because it was a retreat for environmentalists. So it's really come full circle for me, my first retreat being a retreat for environmentalists, and this retreat here at Deer Park. It was a little different back then, though. We had, I would say, a very angry group of environmental activists from Greenpeace and Rainforest Action and most of the NGOs that came to that. And I think I was one of two corporate environmentalists coming from a company. There was somebody from Compaq Computer back then, and myself. And but the practice brought us all together, and it was amazing that by the end of the retreat, there was a much different attitude. In fact, Ty had the first 4 days of the retreat be silent and fairly strict silence, no discussion in between. And I think that by the time that people were able to talk, they spoke from their hearts and really saw a change. And another part of that retreat that really struck me and stays with me today is that taking care of yourself is taking care of the earth, and that all of us need to take care of ourselves to do our work in protecting the earth. So one other thing about my practice is that I'm an aspirant for the Order of Inner Being, and am part of the Earth Holder Sangha. And for about the last year or so, I've been getting up every morning with a gatha. It's also one of the book I bought at the retreat in Malibu in 1991 was a new book by Ty. At that time, it had just come out, Present Moment, Wonderful Moment, which is a book of gathas to use throughout the day. So in my past 25 years of my practice, I've been using gathas regularly. And the gatha for in the morning, getting up in the morning and waking up this morning, I smile. And I've really found it's a wonderful way to start the day with a smile and to have gratitude to be living on this beautiful earth. And then, 24 brand new hours are before me, and I vow to live fully in the present moment and to really take that to heart, waking up, and to appreciate things in the present moment. And as much as I can, carry that into the day. And it's really had an impact on me, and also with the part about to look at all beings with eyes of compassion. And that's not only the people that I encounter, but also myself, have compassion for myself as well. And so I think that looking at having compassion for all beings, part of that is realizing we're all one, and we are at one with the earth as well, and that we are the earth, and that total interdependence. And just when I came out here this week, ran across a quote from John Muir, who was very involved in starting the national parks here in California. And this was from 1911, and he said, "When we try to pick out anything by itself, we find it hitched to everything else in the universe." And so to me, that struck me as talking about the interdependence of things. And this has inspired me to share my knowledge now that I am retired from active work as a corporate environmentalist, but want to share my knowledge and insights and to help with our environmental challenges and to continue to learn and grow. So at yesterday's Dharma talk, the sister mentioned climate change and potentially the end of our civilization. And so where do we put our attention? And I know that's different for each one of us, where we need to put our attention in addressing that issue. And from Brother Fafu's presentation this morning, that we need to water the seeds that make us happy and give us energy. And I think that's important as we choose how we want to work on climate change or other environmental issues. What are the seeds that give us energy and make us happy? So I'm going to be talking about from a climate scientific basis today, and where I think attention is needed from a scientific view. So before I start, I would like to ask what are the questions you have. So if you could share your questions, then there's a lot of different areas that we can go, a lot of different directions. I have some things that I think are important to cover, but I want to know what's important for me to cover for you. So please just raise your hand or signal me somehow, and Brother will give you the microphone because we'd like to record your question.
Thank you for this opportunity to ask you some questions. I am only a hobby scientist, so I'll try to ask a question that probably is a little more for the common person. I've read some things and seen some people speaking recently who are scientists who say that climate change is not man-made, it's just another cycle of the earth that is normally occurring, and that the 97% of those scientists who do say climate change has some aspect of man contributing to it are all affiliated with the United Nations climate, whether it's a committee or group. So that is one question. Would you like me to hold at that or give you a couple?
Okay.
Okay. You might be perceiving that, when I have conversations with friends, I don't want to argue with them or be rude, but I need to know what some answers would be. I don't want to sit there mute when they say some of these things. And One of the other is that I see and hear this argument a lot from people that Al Gore and others just kind of made this up because they're going to make money off of alternative energy, which kind of causes me to scratch my head. It would seem to me that the oil companies and the dairy industry and the meat industry, for one, would have more at stake to lose financially. So I just, I would just like some factual information that I could have on hand. Thank you.
Okay, great. Other questions? Oh, over here, over here.
Yes, we'll start on this.
Hi, I just wanted to thank you for sharing all of your knowledge with us. And I wanted to ask, in the United States, a lot of Americans, friends that I talk to, say that they don't need to do anything because China and India are really the ones that are the big problem. And so I just wanted to hear your thoughts on that. Thank you.
Thank you for the opportunity to ask questions. One of my questions I think was just stated actually, but I was wondering some of the data that I've seen, especially related to, because I'm a avid bird photographer. A lot of the data.
Avid what? I'm sorry.
Bird photographer.
Okay.
So I've seen data, from Costa Rica that date back to the 70s, and they've shown the temperature increase since back then. And I was wondering if, 'cause I hear about birds becoming endangered because of their habitat disappearing. Has that been, I guess, continuing since the 70s? I guess, what's the progression? I mean, we hear about climate change, in the last 5 to 8 years, but obviously, if you've been involved with the Clean Air Act since the 90s, is this something that's actually been happening for a lot longer, and the pace just picked up because of the developing nations?
Okay, yeah.
Hi, Keith. I also just want to say thank you. I've been very excited about this retreat and an opportunity to kind of put my mind in this place and in what I felt like would be a very safe and a collective way. I think like a lot of people in the world, I've been ignoring thinking about this because I was afraid that it would depress me or that it's so enormously complex. I felt a little combination, I guess, of ignorant and intimidated by the subject. So I'm really happy to be thinking about this and have been reading and trying to study a little bit for the last couple of months in preparation for this weekend. And where I end up is a place where I feel like I'm just starting to grasp how complex the whole thing is. Like even the fact that there are people who call themselves scientists that are still denying man-made climate change, like speaks to the complexity of it to me, like that's even possible. And so I tend, from what little I've been able to look at in the last couple of months, to think that climate changes or man-made climate change is a real thing. I tend to agree with that camp. But within that, I see such a huge range of prediction. And because there are so many economic and political sort of accusations being volleyed back and forth between the various camps, I find it difficult, number one, to know who to trust and what statistics to trust, because of course they're all backed up with tons of numbers and statistics. And number two, I find it difficult to know, like, sort of even range of the severity of the problem and the timeline of the problem, who to believe, you know, because I hear some people say, like, 5 years from now, everything's going to be completely different than the world we know, and others seem to be so much more moderate, like 50 years from now or 100 years from now. And so those are kind of my two general sort of, they're bigger than questions, I guess, but areas of ignorance.
Okay. Good, good. Well, that's good. I can I'll make sure that during the course of the presentation, I'll cover all those questions. And if questions come up during the presentation, please, I'll leave some time at the end and we can have a discussion. We're a small enough group here that can have a good discussion at the end as well. So before I start, brother, would you like to say a few words about anything? No? Okay. Well, let me start with talking about the greenhouse gases, and I'll just go through this quickly, but Kyoto Protocol, 6 greenhouse gases, and you can see in this diagram here, the majority of greenhouse gases are your carbon dioxide, which are a result of burning fossil fuel, and from various industrial processes, carbon dioxide. We also see carbon dioxide from forestry and other land use. It is being emitted. Part of that is deforestation, burning of forests. Methane. Methane is a more potent greenhouse gas, about 25 times as potent as carbon dioxide. I'll talk about that a little more later. And there are various methane. It's from sources of, animal manure. Nitrogen that goes on agricultural land is another source of methane. And then your nitrous oxides, again, a more potent greenhouse gas, but it's a smaller portion. And then the fluorinated gases, or F gases. And they're a very small percentage, but they have a very high global warming potential, so they are an important segment of greenhouse gases. And I'll talk about those a little further later on as well, but I wanted to just give a basic of what we're talking about with greenhouse gases. And historically, going back to 1750, we can go back and track the emission of these greenhouse gases. And from 1750 to 2011, there have been about 2,000 gigatons of greenhouse gases emitted into the atmosphere. But about half of those, the greenhouse gases shown here, were emitted in the last 40 years. So since 1975, even though we've been tracking that since 1750, so the rate of greenhouse gas emissions has greatly increased in the industrial age. And I think that's an important thing as we look at whether this is man-made or not, because we're seeing the increased population and increased industrial activities, that big increase over the last 40 years. Yes. Percent as far as total greenhouse gases being emitted. This chart is from, I think, 2010. Yeah. So this is a little complicated. I'll try to explain this. This is looking at the current emission rate, historical emissions of greenhouse gases this is from 1950, but it doesn't start at zero. It would be zero at 1750. But we're right about at that 2,000 gigatons. And a gigaton is 1 billion metric tons of greenhouse gases. And the information, and this is from the Intergovernmental Panel on Climate Change. I'll be talking about various things, and the data that I'm using is from the Intergovernmental Panel on Climate Change and their fifth assessment report that was issued last year prior to the climate summit in Paris. You have a question? This is an intergovernmental panel under the United Nations, but it's an independent panel of scientists. And so it's not just UN scientists. This is from global science. There are people in all sorts, not just governments, but industry that are part of that panel. So it's not just UN employees or something, or government employees even. It's scientists from around the world. And some of the other slides, scientific organizations like the World Resources Institute, the World Wildlife Fund, the Carbon Disclosure Project, which CDP now is their name. So there will be some other sources I'll use as well, but highly credible in the scientific community. So they are looking at some different scenarios, and this somewhat gets to the question about the range of predictions and the complexity of this issue. So the 2,000 gigatons we're at, and if we just keep on business as usual by 2100, by 2100, we're going to be having annual emissions over 100 gigatons, probably around 120. They've run different scenarios, and the one that I'm going to be talking about is scenario RCP 2.6, and that's the blue line. So it shows that these emissions need to be coming down, and it shows them coming down to 0 by 2100, and there are various concentrations here, various concentrations, and the blue concentration is keeping it, this one on the RCP 2.6 between 480 and 530. And that concentration of CO2 in the atmosphere would keep us below the 2 degrees C in temperature rise from pre-industrial levels. So that is a scenario that they're looking at that we need to be on in order to really keep the global warming at a level that would allow us to not see the great impacts of global warming. So this shows where we're looking at that scenario again of 430 to 483 degrees, the one of 480 to 533 degrees approximately. And the cumulative greenhouse gases, we've got to stay about 100 or 1,000 of greenhouse gases concept, in that these gases accumulate in the atmosphere. And as I said earlier, about half of those were emitted in the last 40 years. So we're currently emitting at a rate of about 49 megatons or gigatons a year. And so that rate really needs to decrease. Last year, it decreased by 1 gigaton. And I don't know if you saw any of the articles, but there were a note of decoupling the greenhouse gas production from economic growth. But I think that is, there are a number of things that happened last year. And talking about China and India and their impact, well, China is the biggest greenhouse gas emitter, and they had an economic downturn last year. And their data is also being reviewed, so I don't know that we can claim that we're really on a path of decreasing greenhouse gas emissions quite yet. One positive impact last year that did have an impact was the growth in renewable energy. And we had a lot of renewable energy coming online. So that's a good trend, and that also is perhaps why we saw it come down last year. I think that trend, especially in the US, where we are, I'll show later that that's our biggest greenhouse gas emitter is electricity and energy production. So the more renewable energy we have, the more we'll be able to decrease our greenhouse gases. So as they accumulate in the atmosphere, the greenhouse gases, we have about 1,000 gigatons, the number here, that we can put up in the atmosphere and by 2050 and still stay below the 2 degrees C. And so that's the estimate that we have now from the IPCC, and it's, they have to bracket that. It's plus or minus so many gigatons, and this is not an exact science, and they're running scenarios, but they've got fairly good confidence that that's around the level that we need to be at. And if you look at this, we have to stay at that level by 2050, that 1,000 gigatons. And if we're emitting at 49, if we continue to do about 50 gigatons a year, that's only 20 years. So that's only going to take us out to 2036. So we're going to have to start reducing sooner, not later. And that's where time really becomes a big factor in greenhouse gases and in this whole issue of climate change. Action as soon as we can to stop that accumulation of greenhouse gases in the atmosphere. So another thing that you've probably seen, and this relates to Al Gore and the question there, is an inconvenient truth. And if you remember from An Inconvenient Truth, Al Gore shows a couple of curves, and I guess I could show that here. So the first one has time, and I think they started probably about around 1970. There's probably data before that, but getting good data. And this was the CO2 concentration in the atmosphere. And so when they're tracking that, you get a curve of the concentration going up. The other curve, again, time, almost exactly like that, average temperature, almost the exact same curve going up. And so this is really what led scientists to start looking at this more closely, and how that temperature was really tracked with the increase in the greenhouse gases in the atmosphere. And last year, it was the hottest year on record. And the thing about it is that 2014 was the hottest year on record before that. And in 2015, it went up by 0.16 degrees centigrade, which may seem like a small amount, 0.29 degrees Fahrenheit. But considering the amount it's been going up, if it keeps going up at 0.16 degrees centigrade a year, well, we're going to go up that 2 degrees centigrade in 12 and a half years. So, again, the cumulative effect and other effects that, some of that is just natural differences in temperature too, but it does raise some concern about the degree that the temperature is going up in relationship to the CO2 in the atmosphere. So I've talked a little bit about time and the issue of how we need to take action quickly. And one aspect of time is the atmospheric lifetime of these gases in the atmosphere. So the gases in the atmosphere, they just don't go up and dissipate like ozone or other things that pollutants and are gone in a few days. CO2 in the atmosphere has a lifetime of 5 years to 200 years. So the CO2 that's going up there today can be around, on average 100 years from now. So again, if we need to start decreasing, because that CO2 is going to be in the atmosphere a long time, and 2 degrees C, we're not going to be able to do anything about that for 100 years. Well, there are multiple impacts of the warming. We're seeing a lot of impacts. One of the things that we're seeing, and somebody brought up the question of Costa Rica and the changes in temperature there. I was just down there in February and went to a sustainable coffee farm, and one of the impacts there is that in the rainforest, which normally gets rain every day, during the time period I was there, we had rain one day, and they're now planting drought-resistant coffee plants because they're seeing less and less rain every year, and that's part of and increases in temperature. And with that, they are now looking back, and that this is not just happening now, but going back to 20 years as they look at the data now. And so there are going to be impacts like that we're going to need to adapt to. It does affect where the zone where like mosquitoes can come up into, and the zones where different animals, birds can live. And so there's going to be multiple impacts, and I'm really not an expert on those impacts, so I can't go much further than that for you, but there are going to be multiple impacts with that warming. Another thing about the lifetime here is that I mentioned that group of F gases and the fluorinated gases too. Those gases, in addition to being very potent and having 1,000 times the impact of CO2, have very long life in the in the atmosphere, and they can be up to 50,000 years lifetime. Those are from industrial processes. Some of them are things like they're used for refrigerants. Some of them are used for making semiconductors. Some are used in mining. There's a variety of applications for those fluorinated gases. And generally they're made to last a long time. One of the properties that they were developed for was persistence and not degrading. And so they did a good job, making things like perfluoromethane. So they have a long lifetime. And right now, the only way that you can get them out of the atmosphere is for the oceans to absorb them, or for the plants and trees to absorb the CO2. And with that, with the more we put up into the atmosphere, the more stress there is on the oceans. And that's why we're seeing things like ocean acidification, losing of the coral reefs, damage to fisheries and things like that will be occurring as oceans are more stressed and start to acidify. So that's one of the outcomes there. And I talked about earlier those emissions from between 1750 to 2011. Well, about 40, because of that long lifetime, 40% of those emissions are still around in the atmosphere. So it's going to be an issue. And in fact, I mentioned the Intergovernmental Panel on Climate Change, and I'd like to just read a statement about this, their scientific basis for this. And it says, the atmospheric resonance time of the greenhouse gases is a highly policy-relevant characteristic. Namely, emissions of a greenhouse gas that has a long atmospheric resonance time is a quasi-irreversible commitment to sustained radiative forcing over decades, centuries, or millennia before natural processes can remove the quantities emitted. So I know everything's impermanent, but these are going to be around for a while. Yes? The question was, how long has it been known, the atmospheric lifetime of these gases? I'm not sure. I think this is the 5th assessment report from the Intergovernmental Panel on Climate Change, and I think they had made estimates on those going back to the first one 25 years ago, and they continue to update that. I know that especially for a lot of these fluorochemicals, they do more testing to determine what their atmospheric lifetime is. I think it's pretty well known for the CO2 and for methane and that, but some of these chemicals, they're coming out with new data and new models on their atmospheric lifetime. Yeah, the question was, do industries know the cause and effect of these fluorinated compounds and their long life in the atmosphere? And it's yes, they do know. And there are companies out there that are coming up with alternatives, and I'll talk about that a little bit later. There are alternatives to those being developed, and so I think innovation and changing processes is a big part of this too, big part of the solution. Yes?
You had a very clear
The question was that the scientists that are not aligned with this view that man-made gases, greenhouse gases, are causing global warming, what do they attribute the temperature change to? I think they were attributing it to just, excuse me, natural cycle of the Earth. That we've seen ice ages and we've seen changes in the Earth, in the temperature of the Earth over time, and that it's just a natural occurrence. So that's at least what I've heard from them. Yes, Sage.
I just wanted to say, and to go along with what you just said, like a lot of my...
Yeah. And one thing that back 60 million years ago, when we had the last extinction on Earth, from what scientists can tell from that period, that the buildup in greenhouse gases during that time occurred over 4,000 years, roughly. And so the rate of increase was about 1/10 of the rate of the greenhouse gases going into the atmosphere today. And so this is something, the rate that we're putting up greenhouse gases today is unique to this time period, this industrial time period. And so I think that is why another reason why we can say it's man-made, because we haven't seen that in the past, that quick growth in greenhouse gases, that type of rate. Something you mentioned about the different industry, I did want to cover a little bit around what are the sources of greenhouse gases. And so these are the major sources. This comes from the US EPA. And so the electricity and heat production, and these are global numbers, about 25%. We've got agriculture, forestry, and other land use. And so the agricultural portion of that, the breakdown is about 15%, and the other 9% comes from deforestation and other land use. We've got industry at 21%. And then transportation is the other big one, 14% globally. And then 6% is directly from buildings. If you include the electricity and heat production for buildings, this number becomes bigger. And then there's some other energy use as well. I think it's interesting to look at this. This is a table from WRI on a global basis. So the thing I like about this table is it shows like energy, but it gives a breakdown, so you can see that there's residential and commercial buildings is a part of where that energy is going, and then into different chemicals, cement, industry, and other uses or activities. Yes. Yes.
Does it actually contribute to the increase of CO2, or is it just you have fewer trees, so the effect doesn't work for now, because now you have fewer trees to kind of absorb the CO2?
Yeah, if there are burning of the forest, there's CO2 given off, but also then you do not have those trees available as a sink for CO2. So it's kind of, if they're burning, it's a double effect of contribution. But you can see they do have, land use change, it's called, and most of that is due to deforestation here as the activity. And then the agriculture, I said it was about, yeah, it's 14% on this chart shown, that portion. And like livestock and manure, over about 5.5% there. I find this chart useful to show not only the different sectors where energy is being used, but also the different activities. And then it also gives the type of greenhouse gas from those activities. One other interesting thing here is they also have a similar chart for the US, and it is different from the rest of the world. I think the world, it has developed in the underdeveloped countries as well. So you see transportation being a much bigger sector here, 27%. And actually electricity and heat is also larger. So we have much more consumption for electricity and heat and for transportation. Of course, agriculture, you don't even see deforestation here because we don't have that in the US. So it's not included on the chart even. But I think the big difference here is in the transportation and in electricity and heat numbers there. And so as we look at that, as we see where we need to put our focus here in the U.S., definitely is on the energy sector, and we need some rapid transformation to reduce the greenhouse gases for energy and heat. So I'd like to quickly switch to another topic, and I'll cover this fairly quickly, but there are also 3 categories of gases that, it's very important that people report their greenhouse gases in a consistent manner globally. And there's a greenhouse gas protocol that's been developed by the World Resources Institute and some other nonprofits, as well as industry. Globally, the World Business Council for Sustainable Development actually supported the development of that protocol. And Scope 1 are direct emissions that come from either directly from manufacturing and from businesses, from their use of fossil fuels or the use of fossil fuels for transportation in their vehicles. We also have another scope called indirect emissions, of which we have Scope 2 emissions, which are basically indirect, like purchased electricity. So if you're using purchased electricity or purchased energy, steam for operations, that's an indirect, but a Scope 2 that companies have to track. As well as that would be a Scope 1 emission for a utility, a power plant, but it would be Scope 2 for businesses. And it also is also transportation, other transportation that bring goods into say a manufacturing site or into a company. And then we have Scope 3 emissions, which are also indirect, but these are a group of emissions that can be either upstream or downstream from a company. And so those emissions are things like that come from the use of a product that a company manufactures. So if you manufacture a light bulb, the energy needed to light that light bulb during its lifetime is a Scope 3 emission for that company. And that can be quite significant for a lot of companies that are in the electronics area, or that a company that has a refrigerant that they manufacture goes out and that refrigerant is one of those fluorinated gases that is eventually released into the atmosphere. So these categories of gases are really important to track so that we understand where we can really reduce. And that's a big area that I was working on the last few years, was looking at products that can help our customers reduce their greenhouse gas emissions. So we manufacture different fluorinated compounds, but we developed at 3M a fluorinated compound that has, instead of a hydrofluorocarbon that's used for fire protection, that has a global warming potential of 3,000, that we manufactured one that had a global warming potential of 1, the same as CO2, and had the same fire protection properties of these other chemicals. So buying 1 pound of our product reduced 3,000 pounds of greenhouse gases from going into the atmosphere. So there are a lot of opportunities like that out there to change processes. And so that's why I think it's important to look at scope 3. And this also gets into sustainable consumption, where we need to think about what we're buying and its impact. So, I mean, getting back to the light bulb, buying a LED is a far better for the environment because it has a lower impact, lower energy use over its lifetime. And there are a lot of consumer products that we need to think about too, and consumers should think about when making decisions and the energy use. And EPA has their Energy Star program, which does a good job on electronic equipment and appliances and things. And I think that's a good thing if people would make their buying decisions based on that. Energy Star. So I wanted to introduce that concept as well because I think it really gets at the consumption end as well as what companies can do as far as energy efficiency and that in their own operations, looking at their supply chain and what they're doing as well. And I think all of that really needs to come together. And I really think that governments are not going to solve this on their own. I think it's going to be a collaboration of businesses working with government, working with non-government organizations. And I'm seeing a lot of great collaborations out there. And one of them is with the World Resources Institute, World Wildlife Fund, and the UN Global Compact, and along with CDP, that they're developing science-based targets for companies. And so based on this client science and what we know about keeping the temperature rise below 2 degrees C, is that companies set targets, goals for the company to reduce their emissions to a level that would be in alignment with keeping that the cumulative greenhouse gases below that 1,000 gigatons. And so they've developed a methodology for companies. It's a sector methodology, so they're calling it a sectoral decarbonization approach. So if you're in the cement industry, you have to come down by a certain rate in alignment because of the emissions from that industry sector. Or if you're an automaker, you need to come down by a certain amount, or utility, and they have a number of sectors that they're looking at. Yes, you have a question?
So which were the organizations involved in that? The World Resources Institute, the World
Wildlife Fund,
Fund, and the UN Global
Compact.
and anyone else?
Yes, CDP, Carbon Disclosure Project. They're going just by CDP now, the acronym, but formerly the Carbon Disclosure Project. Yeah, and in full disclosure, I've been helping them work on a manual that is in a draft form, but will be coming out later this year to give guidance to companies. And we're already seeing there are, I think since the Paris summit, we've had 35 companies that have signed on to that, and 148 companies have agreed to set science-based targets as well. And so it's growing, that effort. And I think that's something that's really important, that we set goals based on that climate science rather than just setting a goal for good PR for the company to say we've got a goal, to have a goal that really matters. And so I see that being a really good trend. And another area is renewable energy. And there is a corporate renewable energy buyers principles that are out there now. It's a program, again, with the World Wildlife Fund and World Resources Institute. And they are working with 51 companies that have signed on to the principles and that are setting renewable energy goals for their companies. And they're also working together on principles about getting better choices for renewable energy versus traditional energy. And one of the roadblocks for doing this is just that a lot of the renewable energy contracts with developers or utilities are pretty complex. And these contracts generally run for about 15 to 25 years to purchase the renewable energy, because it's a big investment for the developers and they want to make sure that they have someone to take that energy. But on the other hand, the cost of renewable energy, wind and even solar in some states, is getting to a point where it's more cost effective to do that over the long term, because energy prices are rising and they're going to continue to go up. And right now there are wind farms in Texas that will give where the cost for the energy from the wind farms is less than what you can get off the grid from other energy sources, fossil fuel sources. So I know that a lot of major companies are investing in those wind generation facilities, wind farms, and are seeing profits in the first year. And so it's, the economics is there now. And I think that's why, as I mentioned earlier, we're seeing a lot more renewable energy coming online. And it's really a good trend, and I really appreciate the work of WRI and WWF in helping companies to get over some of these hurdles and look at different third-party financing vehicles and working on simplifying contracts and coming up with standard type contracts for these wind farms and solar farms as well. And an offshoot of that too is community solar gardens. And this is something we have in the state of Minnesota with our main utility. And that gives not only companies, but it gives communities a chance to purchase solar energy at a reduced rate and to actually help consumers save some money but while purchasing solar, and especially giving the opportunity to people who maybe can't install it themselves, they don't have the financing or the money available, or they live in an apartment, or they live in a shaded lot or something that is not, they can't install their own solar. And so the community solar garden, they can purchase from a larger garden, can purchase energy for their home or for their community. I know the city that I live in, we're looking at purchasing, we already have rooftop solar on the city hall, but we're looking at also purchasing from a solar garden the rest of the energy for the city. So there are things like that too that, as we work with utilities and regulators, and I know that WWF and WRI are working with utilities as part of this as well to get these offerings available. And the last thing I'll mention before I open it up for further questions here, we've got about 10 minutes left, is the EPA Clean Power Plan. And I don't know if you've read about this, but under President Obama, the Clean Power Plan was developed to align with the Paris Agreement, and that I talked about earlier that the utilities, the energy production part of it was the biggest sector in the U.S. So this is going right at utilities and really requiring them to develop a plan to offer clean power. And it was recently, there was a Supreme Court decision 5-4 in favor of a few petitioning states and utilities and the coal companies that the federal government was overreaching its bounds to establish a national plan. And so with that Supreme Court decision, that's been put on hold temporarily. But in the absence of that going forward, companies like Google, Microsoft, Apple, and Amazon have filed a 35-page statement supporting a national policy for clean power. And that last summer, actually, 365 companies, along with 29 states, also came out in support and encouraging implementation of a clean power plan. I think these are important issues, and what we can do here in the U.S. is support things that are going on around renewable energy, getting clean power. It's very well, it's the largest sector, so why not go after that one first? And there's a lot of other things. I mentioned products and a lot of other ways we can all contribute. But we need to, from the data, the science, need to look at what we can do to keep that cumulative greenhouse gases below the 1,000 gigatons to have a chance at keeping the temperature rise to 2 degrees C. So questions, yeah.
I have a hard time deciding which nonprofit organizations to contribute to financially to help achieve these goals. The World Wildlife Fund, is that a nonprofit?
Yes, it is. Yeah, I would say from my experience and the ones that see a lot of the major companies that are leaders in climate change, that World Wildlife Fund, the World Resources Institute, Environmental Defense, those are three of the top ones that, as far as being scientific in their approach to what they do, and also that because of their credibility are influential in working with governments and others. Yes? Yeah, the question is around, driving an electric car versus other cars and the trade-off for the CO2 emissions. And it does get complex with electric car. I think the best thing to know that you're contributing is to buy a fuel-efficient car. And an electric car, because the energy has to come from somewhere. It's coming from a power plant. If you are purchasing renewable energy, solar power, that's coming, maybe you have your own solar panel that's charging your car, well, then that is the best thing. But if your energy, your electricity is coming from a coal-fired power plant, well, then it's probably not really helping. And that's been one of the issues about electric cars is, it depends on what your source of electricity is. Yes. The question was about the variability in the weather and changes and more in severe weather and kind of, yeah. Well, that's not my area of expertise, but I've read a little bit about that climatologists are attributing the variability and the strange weather patterns that to climate change, and that it's impacting the various weather patterns in different areas. And some may be warmer, some may be hotter, droughts, more rain in one area. It's variable, but I've heard it called climate weirding, and that it's just strange weather occurrences. And so I'm not an expert there, but there are climatologists that are saying this is due to the change in climate. Yeah. Yes. Okay. The question was around my own feelings about whether we're going to be able to hit that 2 degrees standard, 2 degrees C global warming. I'm optimistic about it. I'm an optimistic person. It will be a challenge, I think, but there are a lot of optimistic things happening right now. I think the renewable energy is really starting to take off, and I think one of the things that makes me optimistic about it is the economics is changing, and I think we're seeing fewer and fewer. I mean, we still have opposition from like the coal companies and from utilities that it's going to be a big capital cost for them to make changes, and they've gotten a lot invested in fossil fuels, and of course the fossil fuel industry itself. But I think that so much of business and industry is behind it that, as I mentioned, 365 companies are supporting the Clean Power Plan. Well, that's a lot of companies in the U.S. And so I'm optimistic that there's going to be a tipping point here where there's going to, things are going to start turning in the right direction. And I guess maybe one thing I didn't cover that was a question from earlier was specifically on China and India. And I think those are where the wild cards are right now. And one of the things that was a consequence of that Supreme Court decision was that China and India, if the U.S. doesn't come along with a plan, Clean Power Plan and other things to meet its goals, then are they going to go ahead with theirs? I think that puts that at risk if that doesn't happen. But on the other hand, I think that there's enough emphasis to make it happen, and I think China and India both have a lot at stake themselves too to make sure they're moving to renewable energy as well. So I'm optimistic there because those are 3 important players, and they need to be part of the reduction. And so yeah, I'm optimistic that we can do that. But we need, more Earth Holder Sanghas, and that's another reason why I'm optimistic. The whole interfaith movement, those in the Buddhist tradition, and also the Pope's encyclical on climate change, and there's, of course, the Lutherans have a group, and Islamic community as well. And I think that their voices, everyone's voice needs to be heard in this, and I think that can be a powerful way to make that change, to get to that tipping point as well.
Question.
Yes.
At our monastery in New York State, we had the ability, and we still have the ability, at least a lot of companies around the U.S. have this type of plan.
There are, well, the question was around, do states other than New York offer clean power to their residents and companies, and
Or do these industries offer?
the industries offer, yeah. We're seeing that in a number of states, that they are offering programs that you can buy wind-generated electricity or solar. Some of them offer it at a premium, and with the community solar, over the long term, you can actually save money. But you need to enter into like a 25-year agreement that you'll purchase energy from that utility. But over the long term, you would actually save money.
We found that's the issue for us at Blue, oil and gas fluctuates greatly.
Yeah. Yeah, I think that's important, that part of the Clean Power Plan is that utilities offer clean power to residents that want to have clean power. And we are seeing that in certain states, certain utilities, but it would be nice to have that be uniform across the U.S. with a federal clean power plan rather than just states. And there are states, a lot of states that have renewable energy quotas that they have to meet by 2020. I know Minnesota has a renewable energy plan and requiring utilities to have a certain percentage of wind and solar available. Yes.
I just wanted to say that to try and make a difference.
Yeah. Okay, the question was about what can an individual do about getting renewable energy if it isn't available in in your area. And I think that, well, it's kind of tough for an individual if you're living in a state that doesn't offer you a lot of options there. And I guess it would be to contact your utility and let it be known that you want to have renewable energy, purchase renewable energy. And I think that would be something to, look at. Maybe if you can organize a group to speak out against that, or just to, I think that the economics are there now, especially in Florida. And I know Florida Power and Light does a lot in that area, I thought, but...
Well, they do, but there's very little solar power. I mean,
yeah.
Very, very little. And I can only assume it's because power is still so cheap.
Yeah. Yeah, if they have cheap other fossil fuel plants then it's tough to compete with having to put in new renewable energy facilities. Yeah. Yeah, I think that's an issue, and that's why we need a federal plan. So I would say that whatever we can do to support the Clean Power Plan, the EPA Clean Power Plan, and I think that maybe we need to look at ways that we can support that as a community, perhaps. Well, we just recently, for the Paris Climate Summit, we supported an agreement there. There were I know that in St. Paul, in Minnesota, we had got sanghas together to do a climate walk to the state capitol in support of an agreement in Paris. So currently it is, yes. There was a petition filed by utilities, coal industry, and a few of the coal-producing states to stop it. That the EPA was overreaching their power, and so it was a 5-4 verdict that Supreme Court put a stay on it. So basically, they didn't say that they couldn't go ahead, but they needed to review things. So I don't know how long exactly that lasts, but I think it could be 6 months.